The Pool Guy Podcast Show. The Pool Guy Podcast Show. The Pool Guy Podcast Show. Yeah!
Hi, welcome to the Pool Guy Podcast Show. In this episode, I'm going to interview Wayne Ivusich from Taylor Technologies. We're going to go over high cyanuric acid and how it affects your pool. We're also going to touch on Adjusted Alkalinity and the LSI Index and bring all of that together full circle for you in this podcast. This is one in a series of 3 podcasts I recorded with Wayne. Leslie's Pool Supplies is a proud partner of the Pool Guy Podcast Show. Leslie's Pool Supplies has been do-it-yourselfers and pool trade professionals' trusted partner since 1963, providing quality products and services to make pool care easy and solutions and expertise to do it right. And I think you're going to find this podcast episode very helpful if you do pool service and you're dealing with pools with high cyanuric acid, or if you're a homeowner and you tested your pool and it has high cyanuric acid. So we'll go over a lot of those details here in this podcast. And then if you want to listen to the other 2 podcasts in this series, in the second podcast, I'm going to talk to Wayne about free chlorine levels and also phosphates, and we're going to touch on nitrates and go over the K2000 series test kits that are NSF certified now. And in the last podcast, Wayne is going to answer some questions that were submitted to me by members of my group. All 3 of these podcasts are a great resource for you on pool water chemistry, and I highly recommend listening to all 3 of them. So let's jump right into the first episode here of the 3-part series. So I'm joined by Wayne Ivusich from Taylor Technologies. How you doing, Wayne?
Really great. How about you guys?
Doing good over here. So you want to tell the listeners what you do over at Taylor?
Sure. I am the manager for education and technical services here at Taylor Technologies. We're located over in Sparks, Maryland. That's about 30-ish miles straight north of downtown Baltimore. I've been with Taylor since 1991. Started out here at Taylor in sales for many, many, many years, almost a little over 2 decades. And then back in 2014 was asked to create a department that's just focusing on education and dealing with all the technical emails and calls that we get it every day here at Taylor. And that's what I've been doing pretty much nonstop since like the latter part of 2014. I go around the country. I teach a lot of seminars at a lot of trade shows. I also present webinars weekly here from Taylor Technologies on a variety of different subjects. Been doing that for a number of years too. I'm a CPO. I'm also an instructor for the CPO course, and I'm a member of the PHTA education committee. That's the group of us evil people who wrote the exams and the manuals and all the courses for PHTA, formerly NSPF and APSP, and been doing that since around 2003. So got a lot on my plate over here. Plus, of course, There's always other little things I do, but that's primarily what I do here.
Okay, and then I'll probably get the webinar information from you at the end to pass on to the listeners. I know I've called Taylor myself a couple times, and they passed me through to you, which is pretty unique for a company that you can talk to someone of your caliber just on the phone by calling tech support. So
yeah, you talk to a real human being.
Yeah, and it's a great company. I call it Taylor. People refer to it as Taylor. No one uses Taylor Technologies, I think, but except for
Taylor Tech too.
A
lot of people could just call it Taylor Tech. Yeah.
You've been around so long that you say Taylor test kit, they know what you're talking about. So.
Right.
So I thought we would spend time talking about the more pressing or complicated chemistry issues that people face. And the one thing that we'll start with is the pools at very high CYA. Now I'm talking over 150, 200. I know it's probably difficult to peg it sometimes. So those pools, in my opinion, are harder to maintain. And what's your take on pools with high CYA?
Yeah, and that is a problem, particularly with pools that have a very short season, like where we are here in the Mid-Atlantic area. Our pool season is roughly Memorial Day to Labor Day, give or take a couple of weeks on either side. So if you have a pool that starts the beginning of the pool season on a stabilized form of chlorine, like a dichlor or trichlor tablet, or you're using cyanuric acid in addition to some other type of chlorine, the numbers just simply go up and up and up. They don't go away. For example, for every pound of dichlor tablets that you use, which is roughly 2 3-inch bucks, per 10,000 gallons, you're adding anywhere from 6 to 7 parts per million of cyanuric acid. And with trichloropucks, it's just a flat 7. So, it doesn't seem like a whole lot, but when you talk about, loading up an erosion feeder and then doing that constantly over season, you're going up and up and up and up. It never goes down. Currently, the recommendation industry-wide is not to let your cyanuric acid get much above 50 parts per million. 30 to 50 is the ideal range. And that seems to be that sweet number, because anything over 50 parts per million is shown not to be very effective. In fact, it kind of flatlines as far as doing anything. It's there, it doesn't do much. There's no additional protection or anything like that. And the closer you get to triple digits, 100, 200, God forbid, higher than that, you can experience something that's called chlorine lock. Doesn't mean you always do, but the likelihood is very high that you will. And what chlorine lock is that instead of cyanuric acid working with the chlorine to keep it in the water longer, so it does the job it's supposed to do, it actually prevents chlorine from getting out to do that job. And it's one of those situations where you might have algae growing all over the place, but yet you have a measurable chlorine reading that would be correct, like 3, 4, 5 parts per million, and you're scratching your head going, what on earth is going on? Well, let's check the cyanuric acid level, and the likelihood of that being very high is a fact. And that's what's causing that whole situation. It used to be, when I started with Taylor, that the prevailing thought was the closer you were to the equator, the more cyanuric acid you can maintain in the pool. So that, for example, if we were in Key West or something like that, down in Florida, of course, that's closer to the equator. And so you can keep higher levels of cyanuric acid. And the more north you get, the lesser amount. Well, that was proven to be wrong by the CDC, who presented a study in 2006 that showed that above 50 parts per million, it flatlines out. And when you get really high, triple digits or so, then there could be other issues going on that prevent proper sanitation and oxidation. So Is it a myth? No, it's not a myth. Is it a truth? It's not a flat out, bang hammer on the nail kind of truth, but the likelihood is that, yeah, it does exist, and it's happened, and I've seen it happen.
Okay. And I've noticed with these pools, people say that there's some algae-resistant yellow algae in it, but I find that the pools with the high cyanuric acid levels, the algae seems to be harder to take care of in those pools, or get rid of, in other words. And it seems to form algae even with a chlorine level of 5 parts per million there, which I think is odd, but it's due to the chlorine not being effective, right?
That is correct. Yeah, you can have terribly high levels of chlorine that you think are doing the job, but if your cyanuric acid level is high to begin with, no matter how much chlorine you have in that water, it's not going to do anything.
Mm-hmm. And then testing for the cyanuric acid, anything over 100 parts per million, most test kits don't test anything above that, and so you have to do a dilution test. How accurate does it get as you're diluting it, half or 1/4?
Well, you've got two like not great situations going on. First of all, you're doing a dilution, and dilutions are fine for the most part. Sometimes colors are, when you're doing a dilution on a test that involves color, that sometimes it's tough to see. But here for cyanuric acid testing, you're using a methodology called turbidimetric, so cloudiness. And with in this case, it's not so much that it's difficult, it's just that you have to do that extra step. And doing a 1-to-1 dilution will allow you to get those higher readings. The kicker, though, with the cyanuric acid test, and I constantly talk about this in my seminars and webinars, is that people are inherently impatient. And that includes pool techs and homeowners who might be doing this testing. And the test, for example, specifically says, pour in or squirt in the solution until the black dot just disappears. Well, in my mind, the word disappears means I can't see it anymore. Not, it just about goes away, or, I can barely see it in there. No, I don't want to see it anymore. So because of that, you're going to get various answers on cyanuric acid levels from the same sample from two people standing next to each other. You're never going to agree on a number. It's always going to be different from everybody else. But I'm a purist. I don't want to see that little black dot disappear. So that's the kicker for testing, whether you're doing it with a straight sample or a dilution to reach higher levels than that. You still have to wait for that little black dot to disappear. That's the kicker here.
Mm-hmm. And the solution that they use, I'll just throw this in there, for testing cyanuric acid, that has a shorter shelf life than a lot of reagents, right?
Actually, no, David.
Okay.
In the most common test kit that we have, the
Hmm.
K2005 complete kit, the only reagent that really has a sensitive shelf life would be DPD number two, reagent number two in Taylor's case. And that's pretty much true for any manufacturer of any testing products where there's a reagent, a liquid reagent in a brown solid bottle. That designates it as an oxidizer. And it's an oxidizer that has I won't call it short, it's more sensitive to air, heat, and light than the other reagents. So that when we put expiration dates or best by or use by dates on our reagents, normally it's 2 years, but all of the oxidizers, the natural oxidizers, usually have about a year and a half. Only opening them and adding drops and whatnot, exposing it to the air, heat, and light again, and it's going to react quicker and go bad. And the way that you know that it's gone bad is that it goes pink.
Okay.
Normally, it should be clear coming out of the bottle. But as far as the number 13 reagent is concerned, that's a clear solution that's pretty hardy, pretty healthy. The only time you might have problems with it is if you're testing samples of water that are less than 50 degrees Fahrenheit. We found that the number 13, some of the products in there kind of clump together, and it looks like little icebergs, little chunks floating
Okay.
in the bottom, and it doesn't work very well. And that's really true, also, David. And I know I digress a little bit, but it's true for any testing. You should try to keep the sample temperature between 50 and 90 degrees Fahrenheit as best as you can. Anything 50, I kind of told you what happens, but anything greater than 90, you're essentially cooking some of the reagents. Particularly the indicator solutions. So if you're doing spa water, for example, which is max of 104 Fahrenheit, you should really collect a sample and let it cool down for a minute or two before you do your testing, or else you could experience these weird odd colors. And again, you're going, what on earth is happening
Hmm.
here? And it's because it's too hot. It's cooking.
Okay. So what I was getting at, so basically the test is accurate. It's just mainly user error with that dot. So the region
Absolutely.
is not a factor in it.
Right. Right.
Okay. Yeah. So that's good.
Good.
And then um, since we're talking about high cyanuric acid, there's
Hmm.
a big push in the industry in some
Hmm.
sectors for the adjusted alkalinity.
Right.
Now, are you someone that believes in doing that every time at a pool, or is it necessary to do adjusted alkalinity every time you test the water?
Yeah, well, I do believe in it because it's true. Number one, and the issue is that you only need to make that adjustment. We'll talk about what that is in a moment. But the only time you really need to make that adjustment if you know for a fact that the sample that you're testing alkalinity for already has cyanuric acid in it. Okay, if it doesn't have cyanuric acid in it, you don't need to do the adjustment, and it gets it totally unnecessary because you don't have any cyanuric acid number to utilize for it. But if you're testing a sample of water that has cyanuric acid in it, because total alkalinity is comprised of a lot of little things. There's no such one thing as total alkalinity. You've got carbonates, bicarbonates, hydroxides, cyanurates, borates, a little bit of sulfate. You've got a whole bunch of stuff in there. And the problem is that if you're doing an alkalinity test that's using stabilized chlorine, there's cyanuric acid in there, you're going to get what we call a false high reading. And you need to adjust it so that you get what we call the carbonate alkalinity reading. And that's the number and the value you should use when you do water balance calculations or any kind of treatment to lower or increase it. And it's really easy to do, easy to make the adjustment. You just take simply a third of your measured a third of your measured cyanuric acid reading and subtract that from your measured total alkalinity reading. And then the resulting number is your carbonate alkalinity reading. So a real quick example would be, and to make my math easier, say you did a cyanuric acid test and it came out to be 90 parts per million.
Hmm.
Well, a third of 90 is 30, right?
Yeah.
You do your alkalinity reading and it comes out to be 130 parts per million. Okay. Subtracting 30 from 130, you get 100 parts per million. And that's your carbonate alkalinity value. And that's what you use again for water balance and for treatment purposes.
Huh.
And but most of the time it's going to be, numbers are still going to be okay. It's that when your measured alkalinity reading is really low to begin with, and you make that adjustment, you could falsely think that you're good for alkalinity when you're really, really not. You're too low.
Got it. So if the cyanuric acid level is at 200 parts per million, that could
Mhm.
be a pretty pretty big problem.
Pretty significant, yeah. Yeah, pretty significant, yeah.
When I first started in the industry, no one really talked about adjusted alkalinity. In fact, I didn't
Hmm.
really hear much about it until maybe the last few years. So,
Hmm.
what's the thought behind it? Why is it so prevalent now?
Well, one of the reasons was, and I agree with you, when I first started, nobody really ever talked about it. I first started reading about it and hearing about it and learning about it probably in the late 90s. And it was the result of a lot of service guys and gals out there doing all these tests and making these adjustments, but it's not on alkalinity, but it's not working. Or they falsely think that their alkalinity level is fine, but yet it's not, and then it's too low, and then you have all the resulting problems with alkalinity. So people were kind of, again, scratching their heads going, what's going on, until finally, and I honestly don't know who kind of discovered it, but it was the realization that, hey, wait a minute, alkalinity has cyanurics in it. Guess what cyanuric acid is? Same name, just about. Duh. So let's make that adjustment. And why it's a third, I'll be honest with you, I don't know. That probably, it's one of those chemical myth buster questions, things that will
Mhm.
never be answered, kind of like who built the pyramid kind of thing.
Yeah.
But again, 30 is the magic number that you,
Okay.
a third is the magic number. Yeah.
Yeah. Good to know. Good to know that.
Yeah.
So here's another thing. I know this. A lot of people don't test for LSI. I
Uh-huh.
know that the Taylor kits come with the watergram wheel, and there's
Right.
of course
Mhm.
apps that will help you calculate it.
Yep. Hmm.
And why is the LSI so important? And can you explain the index?
Sure, sure. The Langmuir saturation index is essentially taking 5 parameters that are measured in pool water or spa water, throwing them into a formula, and then getting a number. And then that number represents whether the water is neither corrosive in nature or scale forming in nature. It's perfectly balanced. In other words, it's not a problem. And this is good for a lot of reasons, primarily, the actual pool or spa itself, and of course, equipment. You don't want your equipment to corrode out. You don't want, you make money, of course, on replacements and repairs and stuff, but you want to make your customers happy and satisfied too. So you want to make their water uh, to the point where it's not going to cause those kind of issues in either direction. So there actually was a guy by the name of Langmuir who worked for UCLA back in the 1930s. Wilfred Langmuir, what is his first name? Wilfred. And he was approached by the then water department in Los Angeles to help them figure out the acidic nature of the water that was coming down from the mountains around LA into the aquifers. For potable water and for industrial water and things like that. So he developed a formula that gave us that ability to evaluate the water as it came through. And it was actually the formula was tweaked in the 1950s uh, for swimming pools, because swimming pools and spas are what we call open water systems, as opposed to piping, which is a closed water system, meaning the sunlight doesn't hit it. So the value of it is that you're taking these 5 parameters, which are the common things: pH, total alkalinity, and this is carbonate alkalinity now. Your adjusted alkalinity, calcium hardness level, the temperature of the water, and something called TDS, which is total dissolved solids. And you're throwing it into a formula. And like you mentioned earlier, Taylor has what we call the watergram. It's a little round, circular slide rule looking thing. And it also makes a great mini Frisbee and a coaster, by the way, too, if you've ever played around with it. But there are also apps, like our SureTreat app has an LSI calculation. Most other apps of the same type have that ability to do that for you. So doing it is more important than who's doing it or what's doing it, but the fact that you should do it. And it's something that, honestly, a good pool service tech should be doing. Now, I'm not saying every time they go out to the pool or the spa for a customer, but at least once a month, so that that you get an idea of how good the water is in that particular pool or spa.
Hmm.
Is it terribly corrosive? Because we know all the problems associated with corrosive water. Or is it leaning towards being scale forming, which is cloudiness and scaling, and that could lead to liability issues, particularly if it's a commercial property. So the LSI is important. Now the other thing too involved in this is that there are a whole bunch of indices out there. other than the Langley saturation index.
Mhm.
There's one you might have heard about this because it's out. You're in your neck of the woods, the Hamilton index.
Yeah, it's kind of
Yeah,
popular here in California.
exactly, because the guy who created it, Jock Hamilton, really nice guy, real character in the industry. He passed away a number of years ago. Very, very nice man. He developed his own index that was very close to what the LSI,
Mhm.
the Langley index, does. He used some different values for things, but essentially, it served the same purpose. It helped define of whether the water's corrosive, scale forming, or neither. It's in balance. Then there's something called the Reisner Index. This is being looked at by a few people in the industry. It came from the industrial world and excuse me, boilers and cooling towers. Then you have the Pecorius Index. You have the Calcium Saturation Index. There's a whole bunch of them
Mhm.
out there. But it's clear that the Langley Saturation Index is the one that's used by a significant majority of us in the industry, to help make sure that the water's good for the people to use.
Yeah, so before we're gonna probably I'm gonna split this up into a few more podcasts here. So
Okay.
let's stop here on this one, and why don't you
Okay.
give them your information to get contact with you with the webinars, and of course you do all
Okay.
the trade shows for the
Right.
chemistry seminars. But go ahead and
Mhm.
throw out the webinar information for this
Sure.
podcast.
Sure. I give a series of 8 webinars every Tuesday from 3 o'clock to 4 o'clock East Coast time. And it's sponsored through a group called GoToWebinar, gotowebinar.com. And if anybody's interested in it, the easiest way to do it is actually to email me. And then I can send them the links that they need to have and go to and use in order to register for the individual webinars. And my email address is very easy. It's Wayne, Wayne, at taylortechnologies.com. And that's no spaces or dashes or dots or anything. And it's plural for technology. So Wayne at taylortechnologies.com. And you send me that email, and then I'll send you back the link for all the webinars. And that's the easiest way to do it. And the good thing about it is, the really cool thing is that there are 4 core webinars involved in those 8. And if you attend the 4 core webinars, you get this really pretty nice certificate of completion from Taylor and from me, signed by me, signed by our CEO, and it's kind of neat, suitable for framing, one of those kind of deals. But it's really neat, and a lot of people like that. Like I said, I've been doing it for a long time, and I probably have given out well over 1,000 certificates over
Wow.
the years. The people really do like those webinars because they're short.
Mhm.
They're anywhere from 30 minutes to 40 minutes. I break it down in specific specific topics like sanitation, oxidation, testing techniques, water balance, hot water chemistry, things like that. So getting the information to somebody who's interested, really easy. Just go ahead and pop me an email over at Taylor. I'm also we have an 800 line that goes into the company. It's 1-800-837-8548, which spells out 1-800-TEST-KIT. Cute, huh? And that goes right into our customer service department. And you can ask to speak with Wayne, and the ladies over there will transfer whomever calls straight up to me, and you'll talk to me and not a robot.
Yeah, that's pretty amazing they can talk to you. But thanks for your time on this one, and we're going to
Okay.
continue for tomorrow. We'll be talking about the chlorine level,
Okay.
and that'll be an interesting one, and phosphates also. So we'll touch on that.
Okay.
And
Okay.
before well, we could touch on the test kits too on the next one too.
All right.
So let's end this one here. So be sure to tune in for part 2 and part 3. I'll have the links to both of those episodes in the description of this podcast. And if you're watching this episode on YouTube, in the description on YouTube, you'll see the links for the other 2 episodes in the series. I think you'll find the information in those 2 episodes equally interesting and informative. And if you're looking for more resources for your pool care, definitely check out my website, swimmingpoollearning.com. I have a lot of helpful web pages there, as well as an ebook available for $9.99. And if you do service for a living, you can also check out my coaching program. For $10 a month, you can text me, and for $20 a month, you can call me. Plus, there's a lot of other great benefits for being part of the group. You can learn more about that at poolguycoaching.com. Thanks for listening to this podcast. Have a great rest of your week, and God bless. Leslie's Pool Supplies has been do-it-yourselfers and pool trade professionals' trusted partner since 1963, providing quality products and services to make pool care easy and solutions and expertise to do it right.